Hello, my name is Jingonelli, and for today I'm going to be taking you through continuous random variables. So, starting off, I'm going to require you to subscribe to the channel. It brings you some good luck in your forthcoming exams, and make sure you watch till the end of this video because there's a trial question for you, and it's having the answers, so you'll need to work out with the solution. So, beginning off, random continuous random variable is one which has a continuous or uncountable domain. For example, the amount of rainfall in a certain city. So the probabilities are given by the area under the curve, which is denoted by f of x. So the properties of f of x or a continuous probability function. One of the properties we're having it is non-negative, i.e. F of x will always be greater than or equal to 0 for all the values of x. So this is how it is represented, having limits a. This is an integral sign having limits of a and b. F of x, the dx will be equal to 1. So this is how it is represented. This is like area under the curve will be equal to 1. So yeah, the area under the curve will be equal to 1. So this is how it is represented by graph. This y will be equal to f of x, and this will be the x-axis having the integrals of a and b. So area is equal to a or a lower limit of a and upper limit of a f of x dx, which is this. So moving on. So in continuous random variables, since we're having an integral sign, we are to carry out integration. So whenever you see this sign here, it is for integration. So what is integration? For integration is the process of obtaining an ordinal function from a given gradient function. Hence it is the reverse of differentiation. So the general rule under integration, a power of x is that we add 1 onto the power and then divide by the new power. So this is what I mean. If you're having dy dx, it will be equal to x of power n. So your y will be equal to x to the power n plus 1. So with integration we add a plus 1 and then we divide by this power, which we have the new power we have gotten. So this is what this statement meant, the general rule. So that is with that. So all this is to introduce you to the continuous the continuous random variable, so that you can get to know what will be happening when they are integrating. So we have indefinite and indefinity and the definity integrals. So with these two, indefinity and the definity integrals, if we have the integral of f of x dx as this, it means integrating the function with respect to x. So if the integral f of x dx is an indefinite integral, so this one will be an indefinite integral because it does not give a definite answer, and we add an attributary constant after integrating. So if at all we are having just a for example, maybe a constant or f of x, and it's not having any limits, it's just an integral sign here, it will require us to add an attributary constant, which is meaning that your answer will be f of x plus c. But since we are not into integration, the deeper integration, I'm just introducing this to you so that you can be able to carry out your continuous random variables when you know what you're doing. So we are to use definite integrals. So with continuous random variables, we get to use definite integrals. What do I mean here? A definite integral is one that gives a definite answer. So with the definite integrals, for them they will be having a definite answer. So for example, you'll be having limits of a and b. A will be the lower limit and b is going to be the upper limit. So integral sign of a and b, f of x dx is a definite integral, where a is the lower limit and b is the upper limit. So hence, if I told you having in the integral sign and a is the x is equal to a and also x is equal to b. So if I'm to take you back area under the curve, this is what they mean. I already tell you these are the integrals on the x-axis, a and b. So that's why they are saying x is equal to a and also x is equal to b. So that is what they mean here. Is what they mean here. So f of x dx is going to be, remember this means integrate it means integrating the function with respect to x. So after that, you have to integrate with respect to x, which is going to give you f of x having limits of a and b, which you will need to substitute in, so that the a will be minus the b when you have put this a in here and also the b in here. So we are going to be seeing that. Let's have an example here. So a continuous random variable has a dp f of x, which is equal to k, which is equal to k x squared for 0 less than or equal to x less than or equal to 4. So find the value of the constant k, and also b, it's asking us for the probability 1 less or equal to x and less or equal to 3. So another thing, make sure you watch the previous videos that came that were before this one. So the solution here, recall that the integral of a and b, integral of lower limit a and upper limit b, f of x dx will be equal to 1. So area under the curve, this simply means area under the curve is equal to 1. So when we are integrating, remember in our question, we are being exposed to 0 and also 4. So x is equal to 0, is less than or equal to 0 and also less than or equal to 4. So meaning our upper limit, we're having the upper limit and the lower limit. So our upper limit is going to be 4 and lower limit is going to be 4. But we are having a constant. And also we are having x squared dx, which is equal to 1. So with this, after integrating, it will require you to always remove the integral sign. So with this, we are going to first of all integrate. So when we are integrating, I told you add a 1 and then you divide by that new power. So this is what I have done, which will give me a 3. Divide by 3, and then I'm done with integrating. Then I'll get to put this in square brackets, and I'll say I'll be having my upper limit and lower limit, which is a 4 and a 0, which is equal to 1. So after doing that, I get to substitute in. I start with my upper limit, always start with the upper limit. This upper limit enters this, and also the lower limit enters this, which I have done here. So I get my 4k to the power 3, divide by this 3 under here, and then minus k minus the lower limit, which is 0. So k times 0 power 3 divided by 3. So this whole thing will give me a 0, and this will give me, when I bring my 4 here, it will give me 4. Sorry, when I say 4 to the power 3, it will give me a 64. So 64 times k, which is this. So divide by 3. This is already a 0, which is equal to 1. So after doing that, I will just cross multiply, whereby my k would now be equal to 3 out of 4. So now I can conclude and say the function of x is going to be equal to 3 out of 4 x squared, which is of limits 0 to 4. So that is with that. So me after finding my k, I'll go to B, which is saying what is the probability of 1 less than or equal to x less than or equal to 3. So since I've already determined A, it will be very easy for me to substitute in. So I'll just come and I say, since now my function is this, this is the function here, and it's having limits of 0 less than or equal to x less than or equal to 4. I'll just come and I say, I'll use the same function, and I'll say now I'm having limits of 1 to 3. So I'll be having my lower limit as 1 and my upper limit as 3, and I'm having my k, which was 3 out of 64 times the x squared, then the x. So with this, when I'm integrating, first of all, I'm going to the constant is brought behind the integral sign. I'm going to take this constant behind the integral sign. After doing that, I'll now need to integrate this one first. So when I integrate, I told you I add a power plus 1 divided by that new power. So then square brackets, I say my upper limit and the lower limit. So I already told you start with the upper limit. So upper limit, when I bring this 3 into the x, it will be 3 to the power 3 divided by 3 because of the new power minus 1. Bring this lower limit now, 1 to the power 3 divided by 3. So after that, I get to first multiply this bracket. I get to first deal with the bracket, that is subtracting it. So 24 out of 3 minus 1 out of 3, I'm going to get a 26 out of 3. So it's going to be 3 out of 64 times 26 out of 3, which is going to give me a 0.40625. So with that, I will say the probability of 1 less than or equal to x less than or equal to 3 is going to be 0.4 if I get to take 2 decimal places. So with that, I'll be done with that. So I'm giving you another example here. So with this, I'm going to require you to follow critically and pay keen attention to what I'm saying, because it's somehow tricky. The continuous random variable x has a PDF f of x, where f of x is equal to, now here I'm having different functions whereby there are two, like we're having the two limits here. So I'm having this f of x is equal to, it can equal to k when you're having limits of 0 to 2, 0 to 2, and also it can also equal to k when it is brackets 2x minus 3, 2 to 3, and then 0 otherwise. So with this, that require me to find the value of the constant k, and also the probability of x less than or equal to 1, and also probability of x greater than or equal to 2.5, and also 1 less than or equal to x less than or equal to 2.3. So with this, solution number 1, I already know that area under the curve, the integral of all x function of okay, I already know that the area under the curve, and this is the function that represents it, is always equal to 1. So when I'm going to integrate, it will require me since they're asking me for the value of the constant k, I'm going to add this. I'm going to add this k plus this k brackets 2x minus 3 brackets, and it's these I will just apply these limits to them. So when I come here, it's what I do: the k plus the k brackets 2x minus 3, and then I apply the limits to them. For the first k, it was 0 up to 2, and for the second k, it was from 2 to 3, which is going to equal to 1. So this is what I have done here. I've used this, and these were their limits, and these were the limits. So I was having two limits there. So after doing that, I will now start substituting in. So I already know that from this first one, now let us focus on this one here. So on the first one, I'm having a 0 lower limit and a 2 upper limit. So k, now k is going to equal to is going to be the same as saying x to the power 0, because it is the same as a plain k, because with x to the power 0 is going to be equal to 1. So our k times 1 will be equal to k. Our x times 1 will be equal to k, which will be this. But since we are dealing with integration, and this function here means that you integrate with respect to x, it's going to now it's going to require me to bring this invisible x which wasn't there. So meaning that if at all this invisible x to the power 0 comes about because it is the same as saying k times 1, and we know that from here the 1 can be represented by saying x to the power 0. Hope there I'm clear. That is how this x to the power 0 comes about. Somebody may be like, yeah, well, how come here I'm not having a what? I'm not having x here, and with this step I'm having x. So this is how it comes about. It's because it is an invisible one, but if at all I say x to the power 0, that's how it can come about. And then this other one will remain the same because we're majorly looking at this side. So after you doing that, but remember we are integrating. So since we are integrating, it will mean that with integration I'm going to add a plus 1 and then I divide by that new power. This is what I have done here. I'm going to add a plus 1 divided by the new power, and then I'll have my limits square brackets 0 and 0 to the power 2. Sorry, I'll be having my limits of 0 and also my upper limit of 2. So plus k. So when I integrate this, it's going to be 2x. Then here, this one is having a 1 here, an invisible one. So 1 plus 1 divided by the new power, which is 1 plus 1 minus. Now, with this, since it's a constant, whenever you get to say a constant and we are integrating, you just a constant will always be equal to 3x. So if you see 3, it will get an automatic 3x. It will get an automatic 3x. I already showed you how it gets the automatic 3x. It comes from this. So this k is also a constant here. So that is how it gets the automatic 3x, because with this I'm going to be getting 3x divided by 1, which will still give me a plain x. So that's how the 3x gets the what? The plain x. So then I square bracket this, and then it's having the lower limit and the upper limit, which is equal to 1. So after doing that, remember this was also a constant, so it will automatically become a kx, like how these 3x how these 3 got the 3x from a 3 to a 3x. So that is with that. So it gets the 3x now, and it's having limits of 0 to 2, then plus. Now with this I'm having 2x squared divided by 2 minus 3x, and then the limits 2 to 3, which is equal to 1. Now with this still remains the same. Now with this is going to cancel with this. The 2 is going to cancel with this, and then I'm going to remain with a plain x squared, then minus 3x, then I put it in square brackets, the limits 2 to 3, which is equal to 1. So after doing that, remember with this I start with the upper limit, so this 2 is going to enter the x, and it's going to be 2, then minus the lower limit, which is 0. So this 0 enters this, which is going to be 2 minus 0, and the k is gonna go outside. So k brackets x squared minus 3x square bracket having limits, lower limits 2 and upper limit 3. So I'm always going to start with this upper limit. So I bring this and I drop it into this, or the whole of this, and then I also minus it with the lower limit, which I would need to drop into the whole of this. So it's going to be 3 to the power 2 minus 3 times with 3 and then minus the lower limit, which is 2 to the power 2, which is this, minus 3 times 2, which is this, then brackets, then I close it off, then which is equal to 1. So after doing that, this side will remain the same, then plus k, this to the power, this is a 9, and this 3 times 3, I'm getting a 9, so 9 minus 9, which is this, and then minus the lower limit, which is the whole of this, so this to the power this I get 4, minus this times this I get a negative 6, so close it off, which is equal to 1. So with this next step, I'll just need to, this will give me a 0, then minus a negative 2 here after me subtracting, so this will give me a positive 2. As I say, this into this, it will give me a positive 2, which is this. So after doing that, now my k bracket 2 minus 0 plus the k minus the k bracket 2 is equal to 1. So when I bring this into this and this into this, it will give me 2k plus a 2k, which is equal to 1. So after doing that, I'll get a 4k, which is equal to 1. So k, which is equal to 1 divided by 4. So after doing that, with now my function of f of x will be equal to this was a k, which is now a 1 which is a 1 out of 4, and the k here will be 1 out of 4 into brackets 2x minus 3, and these will be their limits of 0 to 2 and also 2 to 3, 0 otherwise. So after doing that, I'll come to b. Now what is b saying? B saying find the probability of x less than or equal to 1, which is equal to this. So it will be, since they have said probability of x or less than or equal to 1, I'll need to go to the function, and I'll get to know my limits are 0 and 1. So where does 0 and 1 fall? So 0 and 1 lies within this. So I'll use this the function of 0 to 2. So I'm going to since it's the limit of 0 to 1 is falling under this, I'll get to use this 1 out of 4. So the probability will be taking lower limit as 0 and upper limit as 1 will be 1 out of 4 dx, which I'll get and substitute in. Remember, this is a constant. I already told you with a constant, it automatically gets the x. So it will be 1 out of 4 times x, and 1 out of 4 times x will be equal to x out of 4, which is this. And I square bracket this, whereby I already start with my upper limit and I subtract it with the lower limit. So it will be 1 out of 4 minus the lower limit, which is a 0, hence giving me 1 out of 4. So after doing that, when it comes to probability of x is greater than or equal to 2.5, I'll go back to my function, and I get to ask myself where there's greater than or equal to 2.5 lie, greater than or equal to 2.5, it will lie within this. So you'll find a 2.5 greater than 2.5 lying within this. So meaning that if the greater than is within this, it will require me to take this 1 out of 4 brackets 2x minus 3 brackets. So I'll just come to it here and I'll use it, and this time round I'll take since they're saying greater than or equal to 2.5, I'll need to take my lower limit as 2.5 and my upper limit to be at 3. Because of this, you can see that with this function, it's having an upper limit of what? Of 3, of less than or equal to 3. So that will be my upper limit. So it's what I will use, and I will take its the f of x, which was 1 out of 4 brackets 2x minus 3 brackets dx. So with this, it's going to be 1 divided by 4. I take this constant behind the integral sign, and then I'll need to integrate this. Now with this, you're already pros, so I don't expect a lot of questions here because you already know how if at all I'm to integrate, I'll just add a 1 here to the invisible one, giving me a 2 to the power 2. So it will be 2x to the power 2, then divide by 2. And I know once it's divided by a 2, I'll need to cancel the 2 down here and the 2 and this 2 here, hence giving me an x squared minus, and since this is a constant, it automatically gets the x, so which is 3 out of 3 times, sorry, which is 3 times x. Then I square bracket, and I'm having my upper limit, which is the 3, and my lower limit, which is the 2.5. So after doing that, I'll just remember I always start with the upper limit. I'll substitute in the upper limit into the whole of this, and the lower limit into the whole of this. So 3 substituting into this, it will be 3 to the power 2 minus this into this will give you minus 9, then minus the lower limit, the whole of this, which is 2.5 into this is 2.5 brackets 2, sorry, to the power 2, then minus this times this, 3 times 2.5, I get a negative 7.5. Then I get to substitute it. I substitute this. I can use board mass, but I'll just need to work out this and this. Then after I subtract them to get a 1.25. So 1 out of 4 times 1.25, which is going to give me a 0.3125. So with that, it will lead me to the last. Which is D, with the solution, which is D, which is P. Probability of 1 less than or equal to x less than or equal to 2.5. So after knowing that, I'll get to know where does this lie, where does the 1 and 2.3 lie. So I'll get to realize that with this, the 1 will lie within this, and the 2.5 will be lying within this. So I want that probability that is in between. That will mean that I'll have to add this plus this, and I'll only need to separate them by where they end at. And this one is ending at 2, and this one is ending at 3, but beginning with the 2. So meaning if I go back to D, I'll first get to say my lower limit will be a 1, which is this, and my upper limit will be at 2. So my lower limit will be a 1, and it's lying within this, and my upper limit will be a 2. And what is that? I'll be taking the function of x as 1 out of 4, which I have done here. 1 out of 4, which is dx. And then still remember my second one is beginning at 2, and they're telling me it should be less than or equal to 2.5, and my upper limit will be a 2.5, meaning that if at all I'm to look at that, it will mean the 2 will begin from here, and it will be less than or equal to 2.5, which is lying within here. So it will require me to take this, which I'll add. So plus this, which is, so this integral, this is the lower limit and this is the upper limit. And remember, it's lying within the second limit, which was having a 1 out of 4 brackets 2x minus 3x, then dx. So this is what I'm going to be working with this probability. So meaning with this, I'll just substitute in the upper limit to the upper limit and also the lower limit. So no, sorry, before I go there, remember this is a constant. It will automatically get the x, and x times 1 out of 4, it will give me x out of 4, and then I'll apply in the upper limit and the lower limit. Then I'm still having a plus, and with this plus, remember I'm now dealing with pros. You already know what happens here to give me 2 to the power x, and then with this, since it's a constant, it will give me 3 out of 3 times x, and then I apply in my upper limit, which is 2.3, and also my lower limit, which is 2. So with this, I'll just need to work out this upper limit. I already told you we start with the upper limit. So this into this is 2 out of 4, and then the lower limit, which is this, and then it will be 1 out of 4. So this is this. Then I add there the other one, which is 1 out of 4 brackets into, now I already start with my upper limit, which is going to be 2.3 to the power 2, then minus still 2.3 times 3, which will give me a 6, which will give me a negative 6.9. Then close bracket, then minus the lower limit, which is the whole of this. So I bring this lower limit into this, giving me 2 squared minus 3 times x, which is 3 times 2, which is equal to negative 6 brackets. Then I close off. So after doing that, with this, after me subtracting this, I'll get my 1 out of 4 plus 1 out of 4, and then I substitute, and this will give me 5.29 and minus the 6.9 brackets minus, now this, all of this will give me a 4 minus 6. So this, when I close the brackets off, moving on to the next step, 1 out of 4 plus 1 out of 4. So this minus this will give me negative 1.61. Then then minus a negative 2 here. Here I'll get a negative 2. So negative 1 times the negative 2, it will give me a positive 2. So close brackets. Then I go to this, once I say 1 divided by 4, it will give me 0.25. Then plus this 0.25 times this negative 1.61 plus 2 to give me 0.3. So this times this, I get 0.0975, then plus the 0.25, giving me a 0.3475. So with that, I'll be done, and this is the trial question I had told you earlier. So try out this question. Continuous random variable has a PDF of f of x, where f of x is equal to kx, and it's having a limit of 0 to 4. So find the value of the constant k, and find the probability of 1 less than or equal to x less than or equal to 2.5, and then I close bracket. This should be in a closed bracket. So that is that. Then your answer for A will be this, and your answer for B will be this, which I ran off to 3 decimal places. So with that, if you get those answers, you would have understood this tutorial. So make sure you watch the previous tutorials and also subscribe to the channel. So thank you so much for watching.